It's so hard to walk in the dark and you can't see where you're going. That's how our lives would be without electricity. Electricity is so essential to our lives. We use electricity to start our cars, to light up our homes and places, to heat our food, to communicate with people across distances, and so much more. In fact, without electricity, you wouldn't even be able to watch this video. But what exactly is electricity? First, we have to understand the structure of an atom. An atom is made of a nucleus and negatively charged electrons that rapidly rotate around it. In conductor materials like metals, these electrons can move between atoms easily. For example, if you have a line of copper atoms and you push the first electron in the line to go to the second atom, the electrons will push each other around in the same direction and at the same time. And this is basically the flow of electricity. Shown here is an electric circuit. An electric circuit is basically a closed loop where electricity can flow. The electrons go from one side of the power source, or in this case a battery, through some copper wire into the load, which is a light bulb here, through again another piece of wire into the other side of the battery. So electric current or electricity can be used to do work such as motion, light, heat, etc. And voltage is the pushing force inside the battery that makes the electrons move around the circuit. You can think of voltage like the pressure in a water pipe. The higher the pressure, the faster the water moves. We can also use amps or amperes to measure the current of the circuit. Amps refer to how many electrons are flowing through a certain point each second. If the current is rated for 1 amp, that means that there are 6.24 times 10 to the power of 18 electrons flowing through a certain point each second. It should also be noticed that electricity can only flow when the circuit is completely closed. If you open a piece of the circuit, current will no longer flow. The electrons can't just jump through the air. Switches use this concept to turn the power on and off. Similarly, fuses open the circuit when current reaches above a certain level to prevent damage. There are also two types of current: direct current and alternating current. Direct current always flows in one direction. You will find this type of current in batteries and small circuits because it is easy to control. Alternating current, on the other hand, changes direction 50 or 60 times each second. You will find alternating current in your wall outlets in your home because it can travel across long distances. This is the basics of electricity. Electricity is a huge part of physics and life science. Next time you turn on a flashlight in a dark room, you'll appreciate the science behind what's keeping it on.